There are over 100 types of herpes viruses, but only 8 of them mainly infect humans. These 8 include Herpes Simplex Virus types 1 and 2, the virus that causes chickenpox, cytomegalovirus, the Epstein-Barr virus, 2 types of human herpes virus 6, human herpes virus 7, and the virus associated with Kaposi's sarcoma, human herpes virus 8. Think of it like this. There are over 100 different kinds of apples, but only 8 of them are the ones you usually find in the grocery store. There is also a virus from monkeys called B virus that can occasionally infect humans. Imagine that most dogs don't bite, but there is a particular breed that might bite humans sometimes. The B virus is like that particular breed. Most monkey viruses don't affect humans, but this one can. All herpes viruses can hide in certain tissues in your body and stay there without causing symptoms, but each type of herpes virus hides in a different place. It's like a burglar who sneaks into your house and hides in a specific room. Each burglar virus has a favorite hiding spot, tissue, like under the bed in the bedroom or in the closet in the living room. Herpes viruses are categorized into 3 groups. A. Alpha. Herpes viruses. This group includes Herpes Simplex Virus types 1 and 2 and the Varicella-Zoster Virus. These viruses multiply quickly, cause damage to cells grown in lab cultures, and can infect many different species. Think of these viruses like a fast-spreading fire that can quickly damage many different types of plants in a forest. V. Beta. Herpes viruses. This group includes cytomegalovirus and human herpes viruses 6 and 7. These viruses take longer to multiply and can only infect a limited range of species. These viruses are like a slow-growing plant that only thrives in certain types of soil. G. Gamma. Herpes viruses. This group includes the Epstein-Barr virus and human herpes virus 8. These viruses have a very limited range of species they can infect. These viruses are like a rare flower that can only grow in one specific spot in the world. Let's understand transcription, genome replication, and capsid assembly. Immediate early genes. Think of this as the virus sneaking into a human cell and starting to set up its command center, like setting up the brain of the operation. This part of the virus tells the cell to make certain proteins that will help control the virus's activities. Early genes. Once the command center is set up, the virus instructs the cell to make tools, enzymes, needed to copy its DNA. This is like the virus setting up a machine inside your cell to create more copies of itself. Late genes. Finally, the virus tells the cell to build the outer parts of the new virus particles. This is like assembling the outer shell and parts of the virus. Virion formation and release, virus spreading. After the virus is fully assembled, it wraps itself in a protective covering as it moves out of the cell's nucleus. This is like the virus putting on a coat before leaving the cell. The virus then travels through the cell, using the cell's transportation system, the Golgi complex, to reach the cell's outer edge. When the virus particles are released from the cell dies. This is like the cell bursting open, releasing the virus, and then the cell can't function anymore and dies. Latent state, virus hiding in the body. Sometimes, instead of making more viruses and killing the cell, the virus decides to hide inside certain cells in your body. It goes into a sleeping or inactive state, where it doesn't cause any problems. This is like the virus hiding out in your nerve cells, waiting quietly. The virus can stay hidden for a long time, but it can wake up and start making more viruses again whenever it wants. This is like the virus suddenly waking up and starting the whole process over again, though we don't fully understand what triggers it to wake up. Let's understand this with a human body example. Cold sores, herpes simplex virus. 1. When you first get infected with herpes simplex virus 1 HSV-1, the virus enters the cells around your mouth. It takes control of these cells to make more copies of itself, just like setting up a factory. As the virus multiplies, it damages the cells, causing a cold sore to appear. Eventually, the virus leaves the damaged cells and spreads. However, after the initial infection, the virus hides in the nerve cells near your mouth. This is the latent state. It stays there, not causing any trouble, until something triggers it, like stress or a weakened immune system. When triggered, the virus wakes up and starts the process again, causing another cold sore to appear. Prevention and treatment in allopathy medicine. Vaccines. There is now a vaccine available in the United States to prevent infections caused by the Varicella-Zoster Virus, which is the virus that causes chickenpox and shingles. Vaccines for Herpes Simplex Virus 2, which causes genital herpes, and cytomegalovirus are being tested in large-scale studies to see how well they work. Passive immunization. Another way to prevent herpes virus infections is by giving someone antibodies directly, called passive immunization. This can help protect against infection or can be used alongside antiviral drugs to treat the infection. Treatment. Herpes Simplex Virus 1 and 2 and Varicella-Zoster Virus. These infections are currently the easiest to treat. Medicines like acyclovir, valaciclovir, and famciclovir are commonly used and have been approved for this purpose. However, these medicines do not cure it. If you want to get a cure of HSV-1 and HSV-2, then buy some herbal ingredients from the open market and prepare the medicines to cure completely. Cytomegalovirus retinitis. For this eye infection caused by cytomegalovirus, the drug ganciclovir is used. B virus. This virus, which sometimes infects humans, can also be treated with the same drugs mentioned above. Epstein-Barr virus and human herpes virus, 6, 7, and 8. Unfortunately, there is no specific treatment available in allopathy yet for infections caused by these viruses. There is herbal medicine, Ayurvedic and Unani to cure it, but these need to be prepared in a proper facility under the guidance of an Ayurvedic doctor based on patient's health status and severity of the infection. Prevention. Example, if you want to avoid getting chickenpox or shingles, you can get a vaccine that helps your body build up immunity against the Varicella-Zoster virus. In the future, there might also be vaccines available to protect against genital herpes, caused by Herpes Simplex Virus 2 or cytomegalovirus, but these are still being tested. Treatment example, if you have a cold sore caused by Herpes Simplex Virus 1 or shingles, your doctor can give you medicines like acyclovir to help control the infection and reduce symptoms. However, if you have an infection like Epstein-Barr Virus, which can cause mono, there isn't a specific medicine to treat it yet in allopathy medicines. We will understand here all the variants in detail with example. Herpes Simplex Virus 1 and 2. Genomic homology, Herpes Simplex Virus 1, HSV-1, and Herpes Simplex Virus 2, HSV-2, are related, but their genetic makeup is only about 50% similar. Despite this difference, they behave in many similar ways. Symptoms and conditions. Mucocutaneous manifestations. These are symptoms that affect the skin and mucous membranes. Gingivostomatitis. This is an infection of the gums and mouth, often seen in children, causing painful sores. Herpes genitalis. This refers to genital herpes, which causes sores or blisters in the genital area. Herpetic keratitis. This is an eye infection that affects the cornea, leading to pain, redness, and possible vision problems. Dermal whitlows. These are painful blisters on the fingers or hands caused by the herpes virus. Other serious conditions. Neonatal herpes. This occurs when a newborn baby gets infected with the herpes virus, which can be very serious. Herpes encephalitis. This is a dangerous infection where the herpes virus causes inflammation in the brain, leading to severe illness. HSV-1 versus HSV-2. Imagine two siblings who look different from each other, only 50% similar in appearance. But they both have the same habits and behaviors. This is like HSV-1 and HSV-2. They aren't identical, but they cause similar types of infections. Mucocutaneous manifestations. Example, if someone has a cold sore, gingivostomitis, on their lip caused by HSV-1, it's similar to the sores that HSV-2 might cause in the genital area, herpes genitalis. Both viruses can also cause eye infections, herpetic keratitis, or blisters on the fingers, dermal whitlows. Serious conditions. Example, a baby born to a mother with active herpes might develop neonatal herpes, a very serious condition. Similarly, if the herpes virus spreads to the brain, it can cause herpes encephalitis, which is also very dangerous. How the virus works. Initial infection. When the herpes virus first infects the body, it starts by multiplying in the outer skin cells, epithelial cells. This causes a small blister, vesicle, to form on a red inflamed area of the skin, erythematous base. Spreading to nerves. After this initial infection, the virus travels up the sensory nerves to a group of nerve cells called the dorsal root ganglia. Here, the virus multiplies for a short time and then goes into a sleeping or latent state. Reactivation and new outbreaks. If the virus becomes active again later, reactivated infection, it travels back down the nerves from the ganglion to the skin or mucous membranes. This causes new blisters or sores to appear on the skin or mucous areas, like the mouth or genitals. Cold sore. Example, imagine you get a cold sore on your lip caused by the herpes virus. First, the virus makes the skin cells on your lip produce a painful blister. Afterward, the virus hides in the nerve cells near your lip, staying dormant for a while. Later, if the virus wakes up, maybe because of stress or illness, it travels back to your lip and causes another cold sore in the same area. This process can happen repeatedly over time. Let's understand the body's defensive mechanism and transmission. Immune system defenses. The body uses several types of immunity to fight off herpes simplex virus infections. Interferon. This is a protein that helps the body's cells defend against viruses. Humoral immunity. This involves antibodies in the blood that target and neutralize the virus. Mucosal immunity. This type of immunity protects the surfaces of the body that are exposed to the outside, like the inside of the mouth and genital areas. Cellular immunity. This involves specific immune cells that attack and destroy infected cells. Severity in immunocompromised people. Herpes simplex virus infections can be much more severe in people with weakened immune systems, such as those with HIV or those undergoing chemotherapy. Transmission of herpes simplex virus 1 and 2. Herpes simplex virus 1 HSV-1. This virus is mainly spread through oral contact, like kissing or sharing utensils. Herpes simplex virus 2 HSV-2. This virus is mainly spread through genital contact, usually during sexual activity. Intimate contact required. For the virus to spread, close, personal contact is necessary, such as kissing for HSV-1 or sexual contact for HSV-2. Immune system. Example, imagine your body is a fortress with different defenses. Interferons are like alarm signals that warn the fortress of an attack. Humoral immunity is like archers shooting arrows, antibodies, at the enemy, virus. Mucosal immunity is like a shield protecting the outer walls, like the skin inside your mouth. Cellular immunity is like soldiers who attack and destroy any enemies that get inside the fortress. If the fortress is weak, like in immunocompromised people, the virus can do more damage. Transmission. Example, if someone has a cold sore from HSV-1, they can pass the virus to another person by kissing them. If someone has genital herpes from HSV-2, they can pass the virus to their partner during sexual activity. The virus needs close contact to spread. It can't just jump from one person to another without that intimate contact. Now we will understand Varicella-Zoster Virus. Primary infection, chickenpox. When someone is first infected with the Varicella-Zoster virus, it causes chickenpox. This usually happens in childhood and results in an itchy, blister-like rash all over the body. Reactivation, shingles. Later in life, typically in adults, the virus can become active again. When this happens, it causes shingles, herpes zoster. Shingles appear as a painful, blistering rash that follows the path of a specific nerve on one side of the body, called a dermatomal distribution. Along with the rash, people often experience severe nerve pain, acute neuritis. Chickenpox. Example: imagine a child who gets chickenpox. This is their first encounter with the Varicella-Zoster virus. They develop an itchy rash with red spots and blisters that spread all over their body. After they recover, the virus doesn't leave their body, it just goes into hiding in their nerve cells. Shingles. Example: years later, as an adult, the virus might wake up and cause shingles. This time, instead of a widespread rash, it appears as a painful line of blisters along a specific area of the skin, like a stripe. This stripe follows the path of a nerve, and the pain can be quite intense, making shingles much more uncomfortable than chickenpox. How does it spread and transmit? Let's understand it. The Varicella-Zoster virus is mainly spread through tiny droplets in the air, like when someone with the virus coughs or sneezes. The virus first multiplies in the back of the throat and nose, nasopharynx. Infection in people without immunity. If someone who has never had chickenpox or been vaccinated, seronegative, is exposed to the virus, it spreads through their bloodstream, viremia, leading to chickenpox. Latency and reactivation. After the initial infection, the virus hides in the nerve cells, dorsal root ganglia, and stays dormant. If it becomes active again later, it travels down the nerves to the skin, causing shingles. Body's defense system against the virus. The body uses several defense mechanisms to fight the virus, just like it does with Herpes Simplex Virus. Interferon, a protein that helps cells defend against the virus. Cellular and humoral immunity. These involve immune cells and antibodies working together to fight off the infection. Risk for immunocompromised individuals. In people with weakened immune systems, the reactivated virus can spread throughout the body and cause more severe illness, disseminated disease. Epidemiology. Contagiousness. The Varicella-Zoster virus is extremely contagious. Almost everyone, about 95% of adults, has been infected at some point, as shown by blood tests, serologic evidence. Transmission. Example: imagine a child with chickenpox sneezes, releasing droplets into the air. If someone nearby who has never had chickenpox breathes in these droplets, the virus can enter their body and cause chickenpox. Latency and reactivation. Example: after recovering from chickenpox, the virus doesn't leave the body. It hides in the nerve cells and stays there for years. Later in life, if the immune system becomes weaker, the virus can wake up and cause shingles by traveling along the nerves to the skin. Immune defense. Example: your immune system is like a team of defenders. Interferons are the messengers alerting the body to the virus, while immune cells and antibodies work together to fight the infection. If the immune system is weak, like in someone with HIV or cancer, the virus can spread more easily and cause a more severe illness. Contagiousness. Example: because the Varicella-Zoster virus spreads so easily, almost everyone you know has had chickenpox at some point, even if they don't remember it. This is why nearly all adults show signs of past infection in their blood tests. Now let's explore CMV. CMV is a common virus that most people carry without knowing it, because it usually doesn't cause any symptoms. For most people, it's harmless. However, it can cause issues in babies and people with weakened immune systems. Cytomegalovirus, CMV. Clinical manifestations. CMV can cause different health issues depending on the situation. Symptoms of CMV. No symptoms for most. Most people don't realize they have CMV, because it often doesn't cause any noticeable symptoms. Flu-like symptoms. If symptoms do appear, they might feel like the flu, including high fever, aching muscles, tiredness, skin rash, feeling sick, sore throat, swollen glands. Genital blisters. In adults, CMV can also cause genital blisters, similar to the symptoms caused by Herpes Simplex Virus, types 1 and 2, HSV-1 and HSV-2. Recovery. These symptoms typically go away on their own within about 3 weeks without needing treatment. When to see a doctor. Non-urgent. You should see a doctor if you have CMV symptoms and are either pregnant or have a weakened immune system, e.g. due to chemotherapy. The doctor might do some tests to see if you have CMV. Complications of CMV. Congenital CMV. If a baby is born with CMV, it's called congenital CMV. Most babies with congenital CMV won't have symptoms, but sometimes they do, which might include rash, yellow skin and eyes, jaundice, low birth weight, smaller head than normal, microcephaly, seizures, hearing problems in one or both ears, eye issues, liver and spleen problems. Testing and follow-up. Babies born with congenital CMV may need tests to check their kidneys, liver, brain, eyes and hearing. They will also have regular checkups until they are around 5 years old to monitor their development and health. Congenital cytomegalovirus infection in newborns. If a baby is born with CMV, congenital infection, and shows symptoms, they might have an enlarged liver and spleen, hepatosplenomegaly, eye inflammation, retinitis, a rash, and problems with their brain and nervous system. Mononucleosis syndrome in older children and adults. In older children and adults, about 10% of people who get CMV for the first time as older children or adults may develop symptoms similar to mononucleosis. This includes fever, feeling very tired, malaise, an increase in certain white blood cells, atypical lymphocytosis, and a sore throat, pharyngitis. Disseminated disease in immunocompromised individuals. In immunocompromised people, people with weakened immune systems, like those who have had organ transplants or are living with HIV, are at higher risk. CMV can spread throughout their body, disseminated disease, and cause severe infections in vital organs, such as the lungs, digestive system, liver, eyes, and brain. Pathogenesis, how CMV affects the body. Where the virus replicates, cytomegalovirus, CMV, mainly multiplies in the salivary glands and kidneys. The virus is released into the saliva and urine, which is how it can spread to others. Slow replication and giant cells. CMV takes its time to replicate, multiply in the body. When it does, it causes cells to become abnormally large. Giant cells, with distinctive features inside the cell nucleus, intranuclear inclusions. Epidemiology, how CMV spreads. Transmission. CMV is spread through close personal contact with bodily fluids like saliva, urine, blood, or other secretions like pee, poo, and through sex from someone who is infected. Prevalence. CMV is one of the most common viral infections worldwide, meaning a large number of people around the world have been infected with it at some point in their lives. Pathogenesis. Example, imagine CMV as a slow-moving invader that sets up camp primarily in the salivary glands and kidneys. It quietly multiplies there, causing some cells to grow unusually large with specific changes inside them. These giant cells are a hallmark of CMV infection. Epidemiology. Example, think of CMV as a very common virus that spreads easily when people share close contact, like kissing or sharing utensils. Because it's so widespread, most people are likely to have encountered the virus at some point, even if they didn't get sick from it. Etiology, cause and nature of CMV. What CMV is? Cytomegalovirus. CMV is a type of virus with double-stranded DNA, and it belongs to the herpes virus family. This is the same family of viruses that includes herpes simplex and Varicella-Zoster, the virus that causes chickenpox and shingles. Dormancy and reactivation. Just like other herpes viruses, once someone recovers from the initial CMV infection, the virus doesn't leave the body. Instead, it stays hidden, dormant in the body. The virus can become active again, reactivate, if the immune system becomes weakened, such as during illness or treatment that suppresses the immune system. Dormancy and reactivation. Example, imagine you catch CMV, and after you get better, the virus doesn't completely go away. Instead, it hides quietly in your body, like a spy waiting for the right moment. If your immune system gets weaker, like if you're on strong medication or very sick, the virus can wake up and start causing problems again. This is how CMV can reactivate, similar to how someone might get shingles years after having chickenpox. Thank you for watching this detailed exploration of human herpes viruses. If you found this video informative, don't forget to like, share, and subscribe for more insights into the world of viruses and human health. See you in the next video.